Hello everyone, it's April 21st. Well, today I spent the entire day trying to set up Firebase. It's not that difficult to set it up, but the thing is I try to get the Firebase Google Analytics the debug view to work. And gosh, that thing is not that thing is very complicated, and it's also, I mean, from my experience getting on that one to work, the debug view works well with iOS. I mean, you have to go through a few loops to get it to work, but it absolutely does not work very well with Android, which is weird, right? Why would you not work with Android? I mean, I shouldn't say it doesn't work. It does work, but the debug view allows you to do analytics almost in real time. So every time like I do some actions in my app, I am supposed to see the actions, the events being recorded in the debug view on the Google Analytics. But with with iOS, I can almost see everything in real time. But in Android, it's just so weird. It doesn't show up in real time. The logging information is just all over the place. I might have done something wrong, so I'm not gonna blame Google for this at the moment, but it's not a good experience for me. And the when React Native, that's the one I'm using, right? When React Native makes version changes, then some of the changes are not really back compatible, so I have to change a lot of my tool chains to do the release. But anyway, that's just whole day, 9 hours. Didn't do much. Just configuration, configuration, fail, configuration again. Tons of Stack Overflow. I mean, at the end of the day, I have to document everything, and then what I'm afraid of is, in a couple of months, React Native rolls out a new release, and most of the documentation will be useless, and I have to do this all over again. This is just, this is endless, right? We rely on Android and Apple iOS to do this app stuff, and we are held to their whim, right? Whenever they want to change some stuff, and we have to change as well, like all the automation we have set up, all the fast lane stuff we have set up. But eventually, it's not going to work because if they don't want it to work in a certain way, then we have to change, and that's just a lot of time wasted. Anyway, that's just a little bit complaint. All right, 3 minutes complaint. That's good enough. Let's get into the stuff. Uh, yeah, nothing much. Let's take a look. Oh, wow, one word, triangle. Is that the Pascal triangle? I don't know. Given a triangle array, no, it has nothing to do with the Pascal triangle. Return the minimum path sum from top to bottom. I have done this before, but not here. Yeah, I clearly remember I've done this, but not from here. I think I've done this from the Euler project, long time ago. Took me a long time to figure this out. For each step, you may move to an adjacent number of the row below. More formally, if you are on I, you can move to either index I or I plus 1 on the next row. So here the triangle looks like this. We want the minimum path. So 2, 3, 5, 1. The minimum path, okay, minus 10. Triangle, yes, okay. So 200 rows. Could you do this with ON extra space, where n is the total number of rows in the triangle? Okay. All right, let's see. I mean, what do you think? Well, what I think is, from the start, we have, yeah, I forgot what's the solution. Anyway, so from each number we have only two choices, right? So we can do a DFS. Basically, just go through all of them. That isn't that the solution, right? Yeah, and if we do DFS, like 2, 3, 6, 4, and 6, 1, that's it, 5, 3. Yeah, that's DFS. This is just a binary tree. This is just a binary, well, it's not necessarily a binary tree, but similar to a binary tree. But we also do memoization because we can compute the minimum number, the minimum sum that we can achieve, say, after visiting 5, right? After visiting 5, the minimum we can achieve is, do we include 5? Yeah, we include 5. So the minimum we can achieve is 6. So if 4 visiting 5, then we know we don't have to go further down, which means we can actually go bottom up. All right, let's write top down. It may be fast to write that, right? So we will create, the memo is associated with each individual value, but it's not, yeah, so it's going to be I and J, right? I rows and J column. What's the total? Well, we have 200, so it's just 200 by 200, right? It's 200 by 200, and we just put everything into infinite, and we're going to visit the first one, and if it's, I think negative, oh, we cannot do negative. So we just put it in infinite, right? So you say if it's infinite, that means it has not been checked yet. So we're going to check, find it's the smaller between the left and the right. Right, so we're going to go left, we're going to go right, and we take left, we see, yeah, we're going to just return that, and then plus me, and then that's it. Okay, so I think that's what, ON? I mean, N is the total number of things, of elements. That's what I think. All right, let's take a look, see if this one works. I remember this question bothered me a lot when I was working on it back in the Euler project. I stopped doing Euler project a long time ago. Anyway, so it's going to be DFS. So we're going to give us a what? Well, a DFS is going to give us a position, right? So I and J, I, J, right? And I'm going to return an int. We say if it's the last, right? So we need to know the, let's call it M, equals len triangle, right? So it's the total number of rows. We also have a dp equal to dp equal to what? Equal to math.inf, I think. Right, gonna be from just import math. So we're gonna do math.inf times m for this in m, right? So that's dp. And then what we're gonna do is if, so I is the row, right? So if I is equal to m minus 1, that means that's in the last row, then we're gonna do dp I ij, right? dp ij will equal to triangle ij, right? dp ij equals triangle ij, and yeah, else, so I is not in the last row, then we say actually, we should say if dp I j is smaller than math.inf, and return dpij, right? Else, if it's this and we do this, actually, we should do this equals, right? Then we do this. Else, we say every value can go both. So that's fine. So then we say dpij, right, equals triangle ij plus min dfs and dfs. Right, so min what? I plus 1, j, and I plus 1, j plus 1, right? This can actually be combined. So we say if it's equal to this, well, we can actually say if I is equal to m, return 0. That's outside, right? And then if this, we don't have to check this. So immediately we just do this. If this equals math, we haven't checked it before, so we do this, and this will just return 0, right? And that's done. We're gonna return dp ij, right? Yes, return dpij because we set it. Otherwise, if it's not, then we can return it directly. So after that, we're just gonna run dfs 0, 0. That's the first one, and we're actually gonna return when this yes, when this return dfs 0, 0. All right, let's take a look. See if this one's correct. We have the triangles, this, right? And the solution is 11. We need to fix all the commas, right? Then it's going to be triangle. This is going to be minimum total called triangle, and run it. Int object is not iterable. Oh, range. Like, why do I even do that? Pass. Okay, so I think this shall pass, but this is not. Let's test the other one. It's what? -10. Length is 1, so yeah. It's not a valid type of. Oh, like what happened? Yep, I think this shall pass. Yep, it's a pass. So this is definitely this is the DFS with memoization, right? Very straightforward solution. We traverse the entire triangle and find and record the min sum starting at each number going down. And the result, yeah, that's it. There's nothing more to say. Run time is, oh shoot, it's way above. How did I pass then? I don't even have a. Wow, I just got lucky. Maybe this is not supposed to pass. Huh. So I think it's ON, right? Yeah, it is ON. Each one I only visit once. So I think it's ON because I only visit, not I, because each number is only visited once. And we run at 108 milliseconds, which is beyond the ranking range. This is pretty bad. All right. I mean, one way to save our face is to turn this into a bottom up. Right? Bottom up already helps. So for bottom up, we go from the last row, right? From last row. So we check this. We still do this, but from the last row, we get all these, and then this will be smaller between these two, and this will be the smaller between these two. This will be smaller between these two, right? So this will be 10. We can actually use the same setup as this one, right? Hold on. How do we? So for example, for this position, so we have the last row, right? This is the bottom, and then for this one, this is going to be 7. Let me write it down. Maybe that's the trick. So we'll have this, and then this position, 6, but it's going to be 7. This position is going to be 6, and this position is going to be 10, right? And then going back up, this position is going to be 9. This position is going to be 10. This is going to be 11. Yeah, we'll build from bottom up, which means I only need 4183, right? And then we can do 41, we can add it together. And then we use the first position because after we use this 4, I don't need to use it again. So I can do pick 41, pick the smaller of the two, which is 1, adding 6. So first we're going to be 7. Next is 18. Pick the smaller, add a 5. So we swap 1 with 6. And next one is 83. 83, smaller will be 10. So it'll be 7, 6, 10. And then we have a 3. But we don't use the 3 anymore. So we take the first 2. And then first 2, smaller is 6. So we replace with 9. And then we take 6 and 3. We 6 and 10, which give us going to be 10. And then 10, 3. But we don't use 10, 3. Next one, I got it. I think I know the smart solution. It's a bottom up. The smart solution is bottom up. The space complexity is O(n), where n is the number of numbers number of numbers in the triangle. This is not this does not satisfy the follow-up requirement where the space complexity should be OM, where M is the number of rows in the triangle. Right? Okay, but this is the solution. So we're gonna just pick the last one, right? dp equals triangle last one, right? Now this is what we're gonna do. For I in range, we're gonna go from len triangle, right? Len triangle -2, -1, -1, right? And then we're going to say for j in range len triangle I, right? So j dp j equals triangle I j plus the mean of dp j and dp j plus 1. And we run this, we're going to return dp 0. That's it. Run it, and then we pass it. So this is the bottom-up dp solution with OM complexity, OM space complexity. The idea is that we start from the last row going upwards. For each row above, the mean sum can be computed as how do we describe this? Let's use example. We start from the last row going upwards. For instance, right? Given this, our dp equals to 4183. Then looking at row 657, we know the mean sum involving 6 is 6 plus min 41. Now I want to put this in a new line. Equals 7. And this 7 can replace the first position in dp because the first position will not be used again when computing the mean sum of the second value in row 657. Thus, as we go through 657, dp becomes 7183, handling 6, then 7683, handling 5, 76 10 3, handling 7. Similarly, we use the same technique for the row 3 4. So 3 will be 9, right? 9 6 10 3, handling 3. Then 9 10 10 3, handling 4. Last in the first row. The first row 2. 11 10 10, 3. Handling 2. The result is the first element of the DP array. Yep, so that's the solution. Good question. I remember it took me a long time back then to solve, so I think I have improved. Always check before we go. Yep, submit. Yes, there we go. That is correct. We got into 84. I think this should be the same, right? Why is it different? Yeah, it's the same thing. All right, so this one go 84 milliseconds. That's also ON, and then go 84 milliseconds. That's 5% ranking. Now, I don't think this is correct. How could this be even simpler? All right, this is good. All right, we're gonna go to the solution to take a look if that's how we expect. I think it is how we expect. It's a medium question. That's fine. It's 120. So I recorded. It's gonna be LeetCode 120. Wait, have I done 120 before? I don't think I've done here. Yeah, no, I haven't done here. So dynamic program, bottom up. Row, column, yeah. Can cause problems, yes. Oh, now I'm gonna do it this way. Bottom auxiliary space. I don't even want to use auxiliary space. Oh, I didn't even use auxiliary space. I do it in place. And it's fine. Time complexity, O(n) squared. Oh, they say n is the number of rows. Okay, that's fine. Flip triangle upside down. Yeah, that's the one. Brain assume model. Column and row and column. Yeah, we don't have to do row and column. Find a minimum path from top. Median suggests we should be working top down. That's true. Like a lot of the time, if you think in the reverse, it's much easier. Plus the minimum of the two cells below it. The only difference is that we need to do the edge case handling a bit differently. A lot simpler because the cells only have one cell above them. Every cell has two cells below it. This is quite normal. If we didn't make a lot of assumptions. Slow. He's a little nervous. Less likely to question our assumptions. Using the top to bottom approach, we'll be finally coding it up to show that we can solve the problem. Solving difficult problems, you need to learn to identify the assumptions you're making, to question them in your mind. This can be things like assuming that input is sorted. Yes, that will be invalid. Yeah, we have, I overwrote the input, so I should say, can I overwrite the input? Oh, environment single threaded. I've never done anything like that. I think that will be very difficult. It's like, oh, we have multi threads in this problem. Yeah. It's a lot of practice, exactly. Yeah, learning how other people think. That's why we always go through the discussions, unless we have found something good. Same complexity, and auxiliary space, the same complexity. Auxiliary space. Oh, now I start to understand. I remember this auxiliary. Yes, I've read this before. I have read this before. I think this is exactly the same as mine. Let's take a look. I cannot read Java. Come on. And it's this for row, current row. Why do you need current row? I don't need current row. Smallest current row. Yeah, we can do it. You don't need current row. Memoization. Yes, we use memoization. Yeah, yes. You don't even have to. You can do, yeah, you can do LRU cache. That's true. That's true. Path, if row, path equals this and this, return path, return mean path. Yep, that's cool. Space complexity. After getting timeout. Who else tried DFS and landed in the solution tab after getting timeout? I mean, I got lucky then. Does seem to be a majority. I mean, yeah, this is a DP. That's true. Try DFS with memo, which I think maybe we use LRU cache. It's not. It's going to be faster. I don't know. Give it a shot. Yeah, definitely give it a shot. So if it's LRU cache, oh, we don't even need this. We just LRU cache, and then we say max size equals none, and then we don't even have to check this, right? Yeah, we don't have to check this. We just say DP. No, we don't even have, we just return this. That's it. If it's equal to 0, otherwise we're gonna return this. And then we do this. Let's try it. I'm not sure. I think this is correct. If you use LRU cache. Yeah, if you use LRU cache. And then this can even be written in one line. Right? We can say return 0 if I equals m, else this. So yeah, like that. Submit. LRU cache should be faster. Yes. LRU cache is faster, much faster. Come on, man. I forgot about LRU cache. It's faster than you set up your own memo. Right? So that's going to be 3. Leveraging LRU cache. Yeah, make the code much easier. I mean, we don't even have to say this, right? We can put len in there. Yeah, we only use it once. Be like this. And this one going to be m. It's going to be len triangle. Yeah. Solution 3. Oh, I didn't have LRU cache. From, I think it's func tools, import LRU cache. There we go. Yeah. That's good. LRU cache. This is one line here, and then boom. Let's do len triangle. Yeah, I just want to see what is the runtime so I can record it. Leveraging LRU cache. Of course, first to run it. Just make sure everything still works. Submit on this one. Probably like 70. Yeah, 76. So 76 milliseconds. Solution. Well, solution is pretty well written, that's for sure. Pretty well written. I think people always say like 2 lines, 3 lines, 7 lines. DP. Oh, one. How do you do in 1 line? Reduce. Ay, ay, ay. Ha. I guess, yeah. No, it has. This actually makes no sense. Yeah, it does not make any sense. If you just post this by itself, of course, it does not make any sense. Oh my god, the last row. What is this? So lambda a b. Okay, so that is the lambda function. Oh, that's the lambda function. We then take the last row. Yeah, reduce the last row. And then we're going to pass the last row into it. Wait, what's A and what's... Hold on. How do you do reduce? You do reduce based on this, right? And then I'm trying to understand. You want to do reduce. Reduce, you have a lambda, which is the value, and each one of these, yeah, and each one of these. For A, and B. Man, which one is which? I honestly don't know. Min DE, zip A, and B, and main DE, F is going to be, B is the upper row, right? B is the upper row. But you have to do it with, okay, my bad. This is just to, I thought it's just get one row. No, this is the entire T, it just reversed it, right? So we pick the first one, I don't pick the first one. So it's going to be the first one, this is going to be the first row, this is going to be the above row, right? And then we do this, that's the pairwise, yes, pairwise to pair with that. So the minimum of D and E, minimum of these two, plus B, which is F, and that becomes the result. Yes, and then it's reduced, so we keep that as a result, and then we go to the next one. Yep, that's good. Yeah, that's good. Good solution. Alright, I admit, this is a one-liner. Oh my goodness, what is this thing? It was just for fun. Yeah. I hope it's just for fun. Oh my god. C++ is one of the most difficult languages. Alright, anyway, we got it. Right, this is the not this one. This is the thing. We just do it more in a way more explainable. Okay, that will be it. That will be it for today. We did a good one. I'll see you guys tomorrow. Adios.